Welcome. I'm Josh Tan, and together with my partner Cesar Mejia Munoz, we'll be discussing our project for CS467 of spring of 2025, AR Arcade Classics, Ghost in the Maze. I'd like to begin by inviting you to think of some classic arcade games. You might be thinking of something like Space Invaders, Pac-Man, Tetris, or even something like this, these old-style arcade machines. And when you hear arcade, it kind of screams old, but what if it weren't? And because of that, we decided to recreate Pac-Man in a modern version, in AR. So I'd like to introduce our app, Ghost in the Maze Pac-Man AR. I'd like to continue by discussing some of the key technologies used in our app. The main technology used here is Google's AR Core. AR Core is a software development kit that allows for AR app development on Android. And basically how it works is it uses your phone camera and accelerometer data to detect feature points in the real world environment, and also track the position of the user relative to the changing environment. You can see the graphic on the right from Google that a user is moving their camera around and that it's identifying these feature points on the couch. What AR Core does is it interprets groups of these feature points as planes. And what makes a plane so special is that a user can interact with it. Someone can tap on the screen. AR Core will detect an interaction with that plane from the tapped position and place virtual objects on the detected planes amongst the real environment. So you can also see in the second graphic how there's a little T-Rex sitting on the table. This dinosaur is obviously not real, but is something as part of the augmented reality experience. The other technology that we made use of is Unity, which is a 2D and 3D game development platform. This contains tools for scene management and other commonly used game design elements. And the key that we were able to utilize is that Unity has something called AR Foundation, which is its interface for AR features. AR Foundation does not contain any AR features itself, but it allows for interfacing with existing SDKs such as AR Core. So because of that, we were able to use AR Foundation plus AR Core, and I guess with Unity, to make an AR app on Android. You can see on the right-hand side here, this little diagram that essentially details the workflow, where Unity is the game engine and development platform that uses AR Core, but Unity is what compiles and builds the app to the Android device, which can also be seen in Android Studio.
In this section of the presentation, we're going to do a gameplay demo. My Android device is connected to the computer, and I'm going to use Android Studio to show you what's happening in the screen. We're going to start with the tutorial. In the tutorial, the user has a box that lets them know what the step is that they need to take in order to move to the next section of the tutorial. The first one is going to be tap on a plane to render the maze. Once we complete that step, that box is going to flash green and it's going to provide me the next set of instructions. Now we're going to toggle the visibility. In this version of the maze, there is no game over screen. So when the ghost actually catches up to Pac-Man, nothing happens. This is done so that the user can go ahead and experience the maze without having to worry about a game over screen. We're going to complete the steps of the tutorial next. We're going to move Pac-Man. We're going to eat a Pac Dot. And we're going to eat a power up. Now we're going to eat the ghost, and we have completed the steps of the tutorial. We're taken back to the main menu where we can actually engage the game. We're going to hit play, and we don't have that instruction anymore. We're going to render the maze, toggle the planes, and as you guys can see, we have way more ghosts. And if you guys are able to tell, our score actually increased. We have a score of 100 now. Once we have a game over screen, we can restart the game or we can return to the main menu. If we restart the game, we have the option of putting the plane again and playing the game one more time. And in the game over screen, you can also return to the main menu. And in the main menu, I can show you the last feature that we have, which is a high score. It provides the list of the highest scores achieved in the application so far. Thank you. Hi, for this section of the presentation, I'm going to provide you with the major contributions that I had for this project. My first major contribution was the creation of the 3D maze. The 3D maze was mirrored to reflect the original Pac-Man arcade 1980s maze. The maze was created utilizing prefabricated assets that were available within Unity, as well as some custom-made ones for the more complex structures like the Ghost and Pac-Man itself. I also created a lot of the game logic scripting. Each one of the ghosts has a unique script that handles their movement across the map with different behaviors as well as different states. For example, when Pac-Man consumes a power-up, the ghosts will change color and they will start dispersing throughout the maze. The ghosts have a navigation agent that utilizes this navigation surface, this blue path, to know what are the boundaries within the maze and where they're allowed to move. I also have different scripts that handle the interactions between Pac-Man and the Pac Dots, the power-ups like I just mentioned, as well as the actual ghost interactions. So if Pac-Man collides with a ghost, this brings over a game over condition if Pac-Man is outside of that empower state. The game officially wins or ends with a winning state if you're able to consume all of the different Pac Dots without colliding with a ghost. In this case, the Pac Dots and the power-ups have a sound attached to them. That's why you see the little sound icon. And then my next contribution to the project was a tutorial. In the tutorial, the user has an extra screen that provides them instructions to follow. Once they complete the instructions, that screen flashes green and the instructions get updated with the next thing that the user needs to do in order to progress. This is a slimmed down of the normal maze where the user doesn't encounter a game over condition. This allows the user to be able to freely explore the maze without having to worry about losing the game right away. Something interesting that I found during the tutorial creation was that passing information between the maze and, for example, my tutorial manager needed to be handled differently because my tutorial manager exists outside of the maze, and the assets that are being referenced within the maze don't exist until it gets actually placed. So some of the scripts needed to modify to be able to pass this information at the appropriate places.
Hi, Josh back here. Now I'd like to go back over some of my own major contributions. The key features that I implemented in this app are the plane detection and anchoring, the player movement controller, the sound effects, and the high score leaderboard. Happy to say that all these features were implemented successfully to some degree. Let's go over the successes, challenges, and eventual solutions. So our original plan was a choice between AR or VR implementation, and we are leaning towards full VR. But after initial research and considering our own limitations and experiences as developers, we kind of pivoted to something else, a tabletop AR recreation of the game. Both of us were relatively experienced with game development and app development, so we wanted to take a step back into something a little more reasonable to handle. And this proved to be a wise choice, but still was not without its own challenges. The main challenge was that we still had to learn new technologies within a fixed timeline. Here are some of the key features that I implemented. As mentioned before, the anchoring. How this works is that AR Core detects the planes, and the user will tap on a plane. The AR Core will register a collision with that plane, and our app logic will place the Unity prefab and anchor it to that plane, making it robust as the user keeps moving around the environment. In terms of the movement controls, I implemented a 2D joystick controller on the screen. This is something that the user can move with their thumb or finger, and Unity will register that movement vector, convert it into a movement direction, which is needed to do from an absolute direction from the perspective of something Unity knows into the user's perspective, and then the character will move in that direction. Sound effects have background music based on scene changes and event-specific sound effects based on collisions and Unity's event system. The main challenge here was finding good free assets with a proper license. It gives me so much more respect for people that design their own audio assets or the challenge of finding assets that are allowed to be used in an indie sort of game. Finally, the leaderboard uses Unity's player prefs feature to save data that persists on a device even when it's closed.
Conclusion. We were able to complete the development of our AR Android application that meets all of the requirements that we had originally set up in our project plan. Our application contains a 3D maze that is rendered in a 3D space. It has all of the game logic, character movement, and sounds that are expected and very nostalgic for a Pac-Man game. And it also contains a very small tutorial. Through this project, we were able to gain a lot of experience in object-oriented programming in C#. We learned how to develop an Android application and how to utilize AR technology. We overcame different challenges, such as the different physics interactions that need to be set up properly, and as well as asset interactions to be able to ensure that things were triggered as we expected them to. As far as next steps, Josh is planning to continue the development of this project through the summer session as part of his next class, CS406. Very exciting. Thank you very much.